Okay, guys, on today we are continuing our conversation into projectile motion. We are going to do some mathematical calculations. Um, and of course, like always, whenever we're doing these mathematical calculations, you're going to show your work, take a picture of it, and upload it into Schoology. Okay, so let me go ahead and share my screen with you all. Okay, so we are in fourth period. So let's click on the materials tab. Fit 6 weeks. Today is April the 7th, and it is a Wednesday. Okay, so for today, we're going to be working on projectile motion calculations part 2. Okay, and again, as soon as you're done with this, as soon as you're done showing me your work, you're going to take a picture of it, and then you're going to upload it here into the submission box right here. Okay, now we're going to be dealing situations here where basically, as we have a cannonball that's being fired, we're going to be solving for the horizontal distance or the horizontal displacement in the x direction for all of these cannonballs. So I'm going to do situation A with you guys, and the rest you guys are going to do by yourselves. Now, guys, in order to solve out these problems, it's going to be slightly different compared to the projectile motion problems we worked out last time. Last time we dealt with situations in which we were firing the object horizontally. Like, for example, imagine that we were firing a cannonball like this that was on a platform, and we were firing it horizontally, like we were firing it straight on, something like this. So we worked on examples like this last time. But this time, we're going to be dealing with situations in which we're going to be launching projectiles at angles. So, for example, I can fire a projectile at 43 degrees and look something like this. I can fire it at 58 degrees and look something like this. Or I can fire it at 71 degrees. So, whenever we're firing projectiles at angles, obviously you should you should be able to see that we're going to be dealing with trigonometry today. So we're going to be dealing with trig since we're going to be working with angles. Okay, you can even have situations where it's like this, where it, sitting on a surface, and you fire an object looks something like this. So we're going to use some trigonometry on today as we solve these problems. Okay. In order to solve these problems, you guys are going to need to use your kinematic equations. And you guys remember this, the four major kinematic equations. However, on today, we're not going to use all four of these equations. In fact, we're only going to use two of them. We're going to use this equation here in yellow. So that's one of the equations we're going to use. That says the final velocity is equal to the initial velocity plus acceleration multiplied by time. We're also going to use our displacement equation. This is another equation we're going to use today. So displacement is equal to initial velocity multiplied by time plus 1/2 multiplied by acceleration multiplied by time squared. Okay, so both these equations are going to be helpful today whenever we're solving our problems. Okay, so with that said, let's go ahead and get started. Again, pull out a sheet of paper, something to write with, and I'm gonna work out situation A with you all. We're gonna do situation A as a class. Okay. So I'm gonna start off by reading the instructions. Okay. It says the pictures below depict cannonballs of two different masses projected upward and forward. The cannonballs are projected at various angles above the horizontal, but all are projected with the same horizontal component of velocity. Rank these situations from largest to smallest according to the horizontal distance traveled by the cannonball. Okay, so everybody got that? So in all of these situations, we're looking for a horizontal distance. In other words, we're looking for the displacement of the ball in the x direction. Okay, so that's what we're looking for in all of these situations. And then after we find those distances, we're going to rank them from largest to smallest. That is the goal of this assignment. Okay, so let me highlight that. We're ranking everything according to horizontal distance. That's what we're trying to find. Now, in order to find the horizontal distance, guys, there are 4 important steps that you guys need to follow. In fact, I'm going to pull up these 4 steps now on a PowerPoint so that you guys will have some idea of what we're about to do. Okay, so um, I'm going to just read through the steps quickly, and then we're going to take our time to work through each problem step by step by step. Okay, so let's look at step 1. Step 1 says you want to find the y component of the initial velocity of the cannonball. In a nutshell, you want to split up the velocity vector into its x and y components. So that's step 1. Okay. Step 2 says find the time it takes for the cannonball to reach the very top of its trajectory. Okay. Step 3 says find the total time the cannonball is in the air. And then lastly, for step 4, you're going to use the displacement equation to find the total horizontal distance the cannonball traveled. In other words, you're finding this distance in the x direction. Okay, that's ultimately what we're trying to find. So using those 4 steps, you guys should be good on how to solve these problems. Okay, so that is the goal for today. Again, we're going to do situation A as a class together. Okay, that is the goal. Okay, let me open up situation A in Kami so that we can annotate everything. Okay, so everybody got out their pencil and paper. Okay. Again, we're gonna work through situation A as a class. All right, awesome. Okay, so remember, the ultimate goal is to figure out the displacement of this cannonball in the x direction. Okay, step 1 says find the y component of the initial velocity of the cannonball. So in other words, guys, the moment this cannonball is fired, we're going to be splitting up these velocity vectors into its x and y components. So notice in situation A, we have a cannonball that's fired at 30 degrees. Okay, and notice, guys, what is the initial velocity of the cannonball? They tell us the initial velocity of the cannonball was 23.1 meters per second. Okay, so what we need to do is we need to take this velocity vector and split it up into its x and y components. Okay, so if you notice, so there we have the initial velocity of this cannonball. And guys, if you notice right here, they tell us that the initial velocity was 23.1 meters per second. Okay. Okay. So the moment the cannonball was released, that's how fast it was going. It was going 23.1 meters per second. Okay. Now, okay, this cannonball here, okay, this velocity vector, you can split it up into its x and y components, right? In other words, we want to find out the moment that cannonball is released from the cylinder, how fast is it moving in the x direction and how fast is it moving in the y direction. So we have an x component, okay, and we also have a y component. Now, if you guys notice in the problem, they actually tell us what the velocity of the cannonball is in the x direction. They tell us that. They give us that. They tell us that in the x direction, our cannonball is moving at 20 meters per second. However, we don't know what the velocity of the cannonball is in the y direction. That's what we want to find, right? Remember, that was step one. Step one says find the y component of the initial velocity of the cannonball. Someone tell me, can someone tell me, if I know this angle here is 30 degrees, how can I find the y component for the initial velocity? Can anyone tell me? What trig function am I going to use, sine or cosine? What do y'all think? Again, guys, I want to find out the y component to this velocity vector. Yes, thank you, Stephanie. I would use sine. Does everybody understand why we would use sine?
No.
Okay, so we will use sine because look at this vector here in green. Jeremiah, is this vector, is this opposite our angle or adjacent to our angle?
The one in green.
The one in green, yeah. Remember, opposite is the one that's across from it. Adjacent means it's touching the angle. So which one is this, the green vector?
Is it adjacent?
No, it's opposite. Remember, adjacent means touching. Like look at the vector in red. The vector in red is touching our angle here, so that's adjacent. The vector in green is opposite. Yeah. So since it's well, in other words, it's across from the angle. Since it's opposite the angle, we're going to have to use sine. Remember, for adjacent, you use cosine. For opposite, you use sine.
All right.
Yeah. So, and we don't have to use cosine because notice they already give us the velocity in the x direction. We need to find the velocity in the y direction, which means, as Stephanie says, we need to use sine. So we need to use our sine function. So let me go ahead and write this down. So sine of theta is equal to opposite over hypotenuse. Okay. So we're using our sine function here. Okay. Now let's just fill everything in. Sine, we're told this angle here is 30 degrees, is equal to the opposite. Well, what is the opposite we're looking for? Remember, guys, we're looking for the initial velocity in the y direction. So I'm going to write that down. So the opposite side represents the initial velocity in the y direction. Okay, right? Because that's what this vector represents, the initial velocity in the y direction. And what is the hypotenuse? They tell us the hypotenuse is 23.1 meters per second. Okay, so everybody follow me so far? Awesome. All we're doing, we're just solving for the side of this right triangle. Okay. Now, can someone tell me 23 point James, 23 point was given. If you look closely, it tells us that velocity was 23.1 meters per second. That was given. Yeah. Yeah. That was something they gave to us. I just wrote it down in blue, but they gave that they told us it. All right, so that number there represents the magnitude of the velocity along this hypotenuse. Okay. Now, guys, how do I solve for the initial velocity in the y direction? How do I get that by itself? Anyone? Yeah, I know y'all know how to do this.
Multiply by 23.1 on both sides.
Exactly. Thank you, Stephanie. Multiply by 23.1. That goes away. Whatever I do to one side, I have to do to the other. And can someone put that in their calculator and tell me what you get? Be sure you're in degrees and not radians. So that's the initial velocity in the y direction when you solve for that. Thank you, Iman. That's exactly what I got. Awesome. The initial velocity in the y direction is 11.55 meters per second. Okay. Any questions on step one? So that's how you do step one. That's the very first step, guys. So you're just going to use the sine function to solve for the initial velocity in the y direction. So in other words, guys, the moment this cannonball was launched, right, it was launched in both the x direction and the y direction simultaneously. But if you solely look at the y velocity, the initial velocity in the y direction is this value right here, 11.55 meters per second. Okay. Any questions on step one? Okay. Step two. Let's move on to step two. Step two says, find the time it takes for the cannonball to reach the very top of its trajectory. So guys, it should be obvious to you all that if you launch this cannonball is going to go something like this. Its motion will look something like this right here. It's going to go up, and then eventually it's going to come back down like this. Okay? So that's going to be the trajectory of the cannonball. And so what we want to find that the time it takes for the cannonball to reach the very top of its path. Okay. So this is ultimately what we're looking for in step two. Find the time it takes for the cannonball to reach the very top of its path. Okay. Remember, guys, in step one, we've already said that the initial velocity of this cannonball in the y direction, initial velocity in the y direction, we've already said it's 11.55 meters per second. Okay, so this number is going to come in handy whenever we're finding the time it takes to get to the very top. Okay. So how are we going to find it? Well, guys, that's where this equation right here comes in. You guys see this equation right here that says final velocity is equal to initial velocity plus acceleration multiplied by time. Okay, so we're gonna use this equation here to solve for the time it takes to get to the very top. So I'm gonna come over here, and again, for now we're solely focusing on just our y direction. Remember, guys, whenever you're solving these projectile motion problems, you can treat y as if it's independent from x. Okay, like you can look at each dimension one at a time. So we're going to focus on y first, then we're going to focus on x. Okay, so we're looking at y as if it were its own thing. So I'm gonna write down that equation. This equation here that says final velocity. So basically, final velocity in the y direction final velocity in the y direction is equal to initial velocity in the y direction plus acceleration multiplied by time. Again, I just took this equation here and I rewrote it, but I'm solely focusing on the y direction. Okay. Solely focusing on the y direction. Okay, guys, let us plug everything in to solve for the time it takes for the cannonball to reach the very top. Let us plug everything in, Okay. We already know the initial velocity in the y direction. The initial velocity in the y direction was 11.55 meters per second. We've already found that. Can someone tell me what is the final velocity in the y direction at the very top? So guys, think logically here. If you take a cannonball and you shoot it straight up, so it's going to go straight up, and solely focusing in the y direction, is going to come out the cannon. It's going to come out the cannon, and it's going to slow down until it reaches the very top. So what is this velocity at the very top? Can someone tell me? At the very top of its path, what is? Thank you, Iman. It's just 0. Exactly. So at the very top is final velocity just 0. Does that make sense, guys? Like it slows down until it comes to a stop, right? Because it has to come to a stop before it can even come back down. Okay. All right, let's keep going. Hopefully you guys are following me so far. Guys, as the cannonball is going up, what is the acceleration of the cannonball in the y direction? Anyone? What is the acceleration in the y? I know you guys know this. What is the acceleration in the y direction? Thank you, Iman. 9.8. Thank you, Stephanie. Thank you, Angelina. Now, guys, to be specific, I specifically want to put negative 9.8. Negative 9.8. The reason why I want to put negative 9.8 because think about it. The ball is going up and it's slowing down. If you guys remember from last semester, whenever an object is slowing down, the sign of its velocity must be the opposite of the sign of its acceleration, and vice versa, right? So since we know we have an initial velocity that's positive and we're slowing down, the acceleration has to be negative. So it is important in this problem here that you put a negative 9.8 because as the object is going upward, it's slowing down. Which makes sense, right? Because it's going opposite of gravity. Since it's going opposite of gravity, since it's going against gravity, it's slowing down. That's why we put the negative. So everybody understand why we put a negative there? I just want that to be clear. Yes, Angelina, the negative 9.8 will apply to all the problems. Yes. Because think about it, in all the problems, the cannonball starts off going up, right? So if it's going up and it's slowing down, the sign of the acceleration has to be opposite the sign of the initial velocity. Does that make sense? Right, because it's moving in the positive direction, but it's slowing down, so the acceleration has to be negative. So that's why it's important that you put that negative there, because that's important for this. That's important for this specific problem because our cannonball is going up and slowing down, right? In other words, it's acting opposite of gravity. Okay. Now, guys, let us keep going. Let us. We want to solve this equation for t. Okay. So with this equation here, I ultimately want to get t by itself. Okay. So in order to get t by itself, guys, y'all should know how to do this algebra here. You see this negative 9.8 times t? I'm going to add that to the other side of the equal sign. Because remember, the goal is to get this by itself. When I add that, that goes away. Whatever I do to one side of my equal sign, I have to do to the other. So I'm just left with 9.8t is equal to 11.55. Okay, hopefully everybody's following me. Now, guys, what is the last thing I have to do? How do I get that t by itself? Y'all tell me. How do I get that t by itself? Anyway.
Divide by 9.8.
Yes. Divide both sides equal sign by 9.8. Thank you, Jerry. Divide by 9.8. I'm sorry. Divide by 9.8. That goes away. Whatever I do to one side, I have to do to the other. So if I put 11.55 in my calculator, okay, so I get a time. Yes, that's what I got, Stephanie. Thank you. Seconds. And of course, I'm going to go ahead and write everything out because on there, since we're doing a ranking test, and I just want to write everything out on their key. It's fine as long as it's close enough. You're good. I'm just going to write everything out because again, on their key, I want to be consistent with their key. Since we're doing a ranking test, where we're going to rank everything at the end. I just want to be sure I'm getting a very precise number for my final answer. You can round if you want to, but I just want to be sure I'm getting a very precise number for my final answer. Okay, so guys, any steps on any questions on step 2? So guys, this number right here, 1.179, that represents the time it takes for the cannonball to reach the very top of its trajectory. So that's step 2. Can I move on to step 3?
Wait, what's step 2? That's the number right there?
Yeah. So this number right here, that's the final answer to step 2. 1.178 seconds.
I have to write all of that down?
You can. Or you can round it. Angelina, what are you saying on your question? I mean, Angelina, you can write the whole number down if you want to. It's up to you. Or you can round. It's up to you. I'm just writing everything out because I want to get an exact number since we're going to rank them at the end. But it's up to you. Christine, that's step 1. Okay, and then step 2. And then guys, let's move on to step 3. We're almost done here. Step 3 and step 4 isn't that bad. Okay. Now we're on step 3. Step 3 says find the total time the cannonball is in the air. Okay. Guys, I want y'all to think logically here. Okay. You all just found that it took 1.17 seconds to reach the very top here. But how can we find the total time the cannonball is in the air from this point to that point? So how can we find the total time? Well, guys, if this right here, if it takes around 1.178 seconds to get up here, how do you guys think we can find the total time it takes to get all the way over here? In other words, guys, notice when the cannonball has traveled to this point right here, it's only traveled half the distance. So how do you think, guys, you tell me, how do you think we can find the total time to go the full distance? What do y'all think? Yes, multiply by 2. Thank you, Iman. Yeah, multiply by 2. And yeah, James, you got the right idea. Yeah, so multiply by 2. So on step 3, guys, in order to find the total time a cannonball is in the air, you're just going to multiply by 2. That's all you would do. So I'm going to take, so in order to find the total time, again, the total time the cannonball is in the air is just equal to 2 times 1.178. 2 times 2 times 1. Okay, and so when I multiply that, this is what I get. So for my total time, and again, I want to get an exact value, so let me. And again, I want my numbers to be very precise, because I'm going to rank everything at the end. But again, if you want to round, you can. So for my total time, I got 2.357142858. Yes, thank you, Angelina. Seconds. And again, if you guys got a number that's close to that, that's fine. I'm more concerned with the process. Okay, guys, any questions on step 3? Just so we're clear, guys, if you know how long it takes for the cannonball to reach the very top of its trajectory, you can easily find the total time it's in the air, because At this point right here, the cannonball has only traveled half its distance. So all you would do is just take this time right here and multiply it by 2 to get the full distance. So that's step 3. Okay? That's step 3. Now, the last step is step 4. Step 4 says use the displacement equation to find the total horizontal distance the cannonball traveled. Okay, so now guys, since we're looking at the horizontal distance, now we're focusing on the x direction here. Now we're focusing on the x direction because what we're asked to find, horizontal distance just means what is the displacement of the object in the x direction. That's what we're looking for. Now, okay, so let us use our displacement equation. And remember, our displacement equation is right here. So our displacement equation says displacement is equal to the initial velocity multiplied by time plus 1/2 multiplied by acceleration multiplied by time squared. So solely focusing on the x direction, okay, I'm going to write out my displacement equation. So my displacement equation for the x direction says basically my initial velocity in the x direction multiplied by time plus 1/2 multiplied by acceleration multiplied by time squared. Okay? So, and again, now that we're focusing on the x direction, we can ignore y for now. We've already used our we've already used our equations to find the information we needed for the y direction. Now we're going to just solely focus on the x direction. Okay. Now, guys, let me ask you a question. The moment this cannonball is fired, solely focusing on the x direction, what is the acceleration of the cannonball in the x direction? Remember, there are no forces acting in the x direction, assuming we ignore air resistance. So if there are no forces acting in x directions, its acceleration must be what? Yes, thank you, Iman. Its acceleration must be 0. So guys, if I take 0 acceleration and I plug it into this equation, 0 times some number is just 0.
Wait. Why is it 0 again?
So this part of the equation goes away. It's 0 because, remember, there are no forces acting in the x direction, Jeremiah. Gravity acting in the y direction has no impact on what's happening in the x direction. Since there are no forces, since there's no forces acting in the x direction, it should move at a constant velocity in the x direction. Does that make sense?
Yeah.
Yeah. So it's just moving at a constant velocity. Constant velocity means 0 acceleration. Okay. So that means this equation here just reduces to displacement in the x direction is basically equal to the initial velocity in the x direction, all of that multiplied by time. Okay, now, guys, we know the initial velocity of the x direction. They actually tell us that. Okay, guys, look at your picture. What is the initial velocity of the object in the x direction? The moment that cannonball was fired, how fast was it going in the x direction? Anyway, just by looking at the picture, they actually tell us. Yes, Angelina, it was moving at 20 meters per second. So that's how fast it was moving in the x direction. Yes, Stephanie, 20 meters per second. So what I'm going to do is I'm going to take 20 meters per second. I'm going to plug it into. I'm going to plug 20 meters per second in here. So the x direction is equal to 20 meters per second. And then what is my time? Well, we've already solved for the time up here. Remember the time? We said that the total time the ball was in the air was 2.357 seconds. Okay. So I'm going to write that in here. So the total time was in the air. I'm going to try to write small. So 2.357 seconds. Okay, so when I multiply 20 by that, let's see what I get. Yeah, Stephanie, that's exactly what I got. Thank you. So so when I multiply 20 by that time, I actually get, let me zoom in so I can write. I actually get 47 point. And again, guys, this is in meters, okay, because we're solving for displacement. And that right there is my final answer. 47.14 meters. So that's how far the cannonball travels in the x direction. Okay. Any questions? Any questions? And you guys, you're going to do the remainder of the problems just like this. Stephanie says this problem took up a whole sheet of paper. That's good, Stephanie. That means you're working. Now, so some of you guys may be wondering, well, you're killing trees, Mr. Taylor. Okay, well, not so much, Stephanie. I'm explaining why. Yes, Angelina, that is the final answer for letter A. That's the final answer for letter A. Okay. Now, some of you guys might be thinking, Mr. Taylor, that was a lot. You actually want us to do that? You actually want us to do that for a total of 6 different problems?
That's
Well,
what the AP wants you to do.
huh?
You're going to be like, this is what the AP test wants you to do.
Well, no, Jeremiah, hold on, yeah, hold on. Let's not get too far ahead of ourselves. Look closely at situation B. Look at situation B. Notice in situation B, the cannonball is fired at an angle of 30 degrees, just like situation A. The initial velocity is also the same as in situation A. However, what's different is the object's mass. So here in situation B, our cannonball is 4 kilograms. Here, our cannonball is 2 kilograms. So the only difference between A and B is the mass. But let me ask you guys a question. Does mass have any impact on the acceleration of gravity? Anyone?
No.
No. So situation B should have the exact same acceleration as situation A. So if everything else is equivalent, guess what? B, yeah, B is going to go the exact same distance as situation A. So if you know your answer for A, then guess what? You also know the answer for B.
B.
So
if I write down the answer for B, are you going to cross it out for not showing my work?
Well, as long as you show your work in A, you're good.
No, okay.
Yeah. Yeah, or you could just write the answer, Angelina, for B. So just keep that in mind. So really, so in all of these problems, so guys, in some of these problems, since they're going to be ties, you don't necessarily have to work. You actually don't have to show me the work for all of them. That's the point. So it's not as bad as it sounds. Now, last thing that I want to tell you guys today, I want to tell you guys how to do your rankings. Remember, as soon as you're done finding the distances for all of these, you want to rank from greatest to smallest. From greatest to smallest. So, what you would do, like, let's just say you're ranking from greatest to smallest. And let's just say you want to, I don't know, you want to rank them like this, where it would be like, I don't know, like A is the greatest, and then you would put B, and then I don't know, you would like put E, and you would keep going. So as soon as you're done showing me your work, just rank from greatest to smallest. And guys, if you have situations where you have ties, you would just circle that to indicate a tie. So I'm going to circle A and B to indicate that they're tied. Does that answer your question, Stephanie? Yeah, you're just ranking from A to just ranking from greatest to least. Angelina, this is how you do the ranking. This is all you do. So yeah. Yes, Stephanie. And Angelina, you're right. It does like asking. Well, it does like using 20 meters per second for the x velocity. The x velocity. Okay. But yeah, so for your rankings, guys, you're just ranking from greatest to least. Or in other words, ranking from largest distance to smallest distance. Just be sure that you put your ties next to each other and that you circle them whenever you're tied. Okay. Angelina, not all of them are going to travel the same distance, so you're not going to worry about that. And don't worry about explaining your distances. Basically, Angelina, if you got if we were doing this problem and all of them did go the same distance, you would just check that they all go the same distance. But that's not the case here for this particular problem. So just ignore that, Angelina. Just ignore it. Yeah. And don't worry about explaining your reasoning. All right, guys, that's pretty much all I have for today. As soon as you're done with showing me your work, you're going to take a picture of everything and you're going to upload it here to the submission box. So this is called Projectile Motion Calculations Part 2. As soon as we are done with our calculations, we are done with projectile motion. As soon as we're done with this for today. Okay, let me stop recording.